Welcome and hello. This is a video lesson in the HEC-RAS controller called Schematic Cross-Section Procedures. So what we're going to be talking about is three closely related procedures within the HEC-RAS controller that all begin with schematic underscore XS. So these will involve providing us the number of cross-sections, the number of cross-section vertex points, and the cross-section XY locations as data points. All right, so let's go ahead and get started. Here on the screen, what I have is a project. Down below is my geometric data editor. So we have two different rivers and three separate reaches, each with cross sections at the upstream and downstream end of those reaches, for a total of 6 cross sections. So keep that in mind. Let's go ahead and check out the procedures in the HEC-RAS controller that we're going to talk about. So let's head over to Excel, click on the Developer tab, and then Visual Basic. Okay, so go up to View then, and Object Browser, select the HEC-RAS reference. This is the HEC-RAS library of sorts. If you don't see HEC-RAS, make sure to go Tools, References, and then check the checkbox for HEC River Analysis System, or you can, if you don't have it listed at the top, you may have to scroll down alphabetical down to the H's. If you don't see it in that list, then you don't have HEC-RAS installed on your machine, assuming you're using a Windows machine. So yeah, like I said, select RAS and then the version. So RAS 66 for me. Click on HEC-RAS controller. And now we're going to scroll down to schematic underscore XS. So here is schematic, schematic underscore XS, schematic underscore XS point count, and then finally schematic underscore XS points. So when I select one of these procedures, it tells you down below that this one happens to be a function. This is the function name. There are no arguments, and it returns a long integer. Schematic XS count function returns the number of cross sections in the current HEC-RAS project's active geometry. So we pretty much know that that's the number 6, right? So 1, 2, 3, 4, 5, and then 6. There's actually 3 right here at the junction because it's the upstream most cross section of this lower reach and the downstream most cross section of these two upper reaches. Actually, I could probably just zoom in and you can see them all, right? So 1, 2, and 3 plus the 1, 2, and 3. All right, so that's the first procedure, the first function. The next function we're going to look at is schematic underscore XS point count. Since I selected that, you can see it is, again, a function. It returns a long integer, and there are no arguments right here in the function definition. This function returns the total number of cross-section vertex points that make up all the cross-section points in the active geometry. And what we're going to learn is that the points returned here is going to be 5 for every cross-section, at least in this model and throughout my testing. It's going to not be every single station elevation value, but it's going to pertain to the 5 points as the endpoints, the bank station points, and then the one centerline point. Okay. So let's go ahead and demonstrate these two functions right now. We'll do a quick demo, and then after that, we'll come back and take a look at this schematic underscore XS points, which is a subroutine and a little bit more involved. All right, so I'm going to click on my worksheet over here. So I'm actually just going to paste in a subroutine that I have prepared. This is the first function here. This is the second function here. And then before that, I need to actually create a HEC-RAS controller object, which I do right here called con, C-O-N, and then this is where I'm opening up the project. All right, so this is the project that we were just looking at. The schematic underscore XS count function is assigned on this line right here, and I assume that's going to be 6. And then we're printing it to the intermediate window on this line. And then further down, we have the XS points count. This is assigned on this line and then printed to the intermediate window right here. Okay, so I'm going to just click on Save, open up the intermediate window by going View and then Intermediate Window. Boom, here it is. And then let's click into the subroutine, Run, and there we go. Okay, basically here is the output. So the first function, the number of cross sections is 6. That looks good. And then further down here, we have cross section point count, and that is 30. So we have 5 different cross section point counts for every cross section. All right, so let's go ahead and add some cross sections and then see how these counts change. So let's go back to HEC-RAS, the geometric data editor. I'm going to just quickly interpolate some additional cross sections within these reaches. I'll go up to Tools, Cross Section Interpolation within a reach. I'm going to select all rivers, and I'm just going to say every 50 meters, add a linearly interpolated cross section based on the two cross sections at the endpoint of each reach. Interpolate. Now we have a bunch of cross sections. So right here, river station 400 right there, and then we have our 350 and 300 and so on. I'm not going to count how many, but we don't have to because we have this subroutine right here. Let's go ahead and file, save the geometry data. In fact, I should probably close HEC-RAS completely. Save, close. Let me go ahead and run that again. Okay, so it ran again. Now we have 23 different cross sections and 115 cross section points. All right, so that's it for the first two functions, the first two procedures, which are a little bit simpler to understand and less involved. I'm going to go up to View, Object Browser. Now, the last of the three procedures I want to talk about is right here. This is schematic underscore XS points. I'm going to close the intermediate window for a moment. All right, so what it says about that is it's a subroutine. There are 6 separate arrays that we need to pass in. They are passed in by reference, so we can just have the subroutine assign the data to these separate arrays. These arrays are zero-based and must be sized accordingly. And once we get into the code itself, I'll explain what these parameters are and what sort of data they hold. Okay, so let's go back to our code now. I'm going to double click on my worksheet. This is where we just were. I'm going to paste in the full version of the code I have prepared. What we saw earlier was this much right here. So everything below it is new. We're going to, let's see, here's the actual subroutine call. So we're going the controller object dot schematic underscore XS points. And then right here are the 6 different arguments that we're passing it. These are arrays that we first create here, and then we size right here with the redim command. First, we have the river station names, then the reach IDs, and then after that, the cross-section start index, cross-section point count, and then the X value and the Y value of those different points. Since these arrays are zero-based, they start counting at 0, we need to actually change the number or redim the size of each of these rays based on the cross-section count, which we get in our first function call right here, and then subtract 1. And then for the X and Y values, the last two arrays we pass to our subroutine, that also needs to be sized as XS points count minus 1, which we determined using our second function up above. Okay. After that, what we're doing is going to print out the array. So I wrote a function further down here to print out the array. Now, instead of writing to the intermediate window, which would be possible if there was not too much data to output, but there's too much data actually output here. So what I'm doing here is instead printing it to the worksheet. We are in sheet 6. So me references sheet 6, and I'm just going to start on row 2. Print out the array name, which I'm passing in as just a string, literal. And then after that, I am looping through the array, and I'm going to print out the contents of the array. The third parameter here is the column. So I'm just going to start at column 2 and go to column 7. So here's column, and then here is column right here. So let's go ahead and check out the worksheet first, just to confirm this is sheet 6 down here. There's no data currently in sheet 6. So once we go ahead and run this subroutine, we should see some data. I'm going to click on save and then run that subroutine. Okay, so the data popped up right here. Let's take a quick peek at it. All right, so river station name, it starts at 400, it goes down to 0. That's the first river reach. After that, we have 2 more river reaches. One goes from 250 down to 0, and the last one is 350 down to 0. So I'm pretty sure this right here is my river C, and this is river D. And then we have the reach IDs, so I could determine the exact reach that it's referring to. And then we have the cross-section start index and the number of cross-section points. So each of these cross-sections has 5 points. So this first cross-section right here has index points 0 through 4, and then the next cross-section has points 5 through 9, 10 through 14, and so on. So the very most upstream cross-section here has the first 5 points in this array, which is right here, 1, 2, 3, 4, 5. And then the next cross section down at river station 350 right here, that would be 1, 2, 3, 4, 5. So it'd be 6. Yeah, it would be these 10 points right here, these 5 XY pair values to represent coordinates from the plan view looking down on the map to represent what is probably the end of the reach line, the overbank, the actual center line, the river crossing, overbank, and the end of the reach line. So just to demonstrate that, let me go ahead and just do a quick XY plot. Let me do a whole XY plot on all of the data real quick, and then insert. I'm going to click on, how about plots, XY scatter. Okay, so this plot is a little bit jumbled, but I think we have a river center line going here, and then another river center line going right down here. Not really what I intended to demonstrate. Let's go ahead and just plot the first two cross sections. So that would be these 10 points. Go to insert. I know this is very hasty. I'm just trying to get a general feel. Here we go. Yeah, so what we have here is River Station 400 and River Station 350. Notice there's 5 points. So here's the river center line through the third point, and then the end of each of the reaches, and then let's see, this would be the left overbank and the right overbank. Just to demonstrate that that is the XY points that's being referred to, I'm going to quickly open up the HEC-RAS model and then change the left and right bank stations for these two cross sections so that perhaps River Station 400 would have bank stations closer to the end of the cross section. And then the cross section here at River Station 300 would have bank stations closer to the center of the cross section. So let's go ahead and do that. And then we'd have to also rerun the script. That's all right. So open up HEC-RAS. Okay, here is the project. Here's the geometric data editor. I'm going to zoom in on our two cross sections of interest, which are these two right up here. Click on cross section. All right, so for cross section River Station 400, I'm going to change the bank station on the left to 20, and then on the right, it's going to be 130. So that's further out away from the center of the river. Apply data. And then one cross section downstream, I'm going to change the 40 to a 60 and the 110 up to a 90. That's one station closer towards the center of the river. So apply data and then exit. Let's file, save the geometry data. I'm going to save the project. I'm going to close HEC-RAS. I'm going to rerun the script here, which utilizes the HEC-RAS controller. And then I'm going to, again, plot these same points we did before. So insert, just give me the scatter plot would be fine, which is right here. And boom. Okay, cool. So this is what I expected. The endpoints are still in the same location. The center line point is in the same location. But here at River Station 400, you can see the left and right bank station locations are further away from the center. And just the opposite is true at the next downstream cross section at 350, where the bank stations are both closer to the center of the river. All right, well, that's it for this lesson. What we talked about was 3 procedures in the HEC-RAS controller. We begin with schematic _XS to get an idea of the different data points within our cross sections in our geometry file.